Alright guys, it's Miss Summers with your notes today. We've been talking this past week about weather, which are your day-to-day conditions. And today we're going to switch gears a little bit and we're going to talk about climate. And today's goal is to be able to figure out what factors affect climate and be able to predict what the climate of a place is going to be given these different factors. So let's start with how climate is different than weather. Climate is basically long-term patterns of weather. All right, so instead of day-to-day, we're looking at averages. A way you can think about this, weather is like your mood, whereas climate is like your personality. Your mood can change from day to day, but overall your personality is probably not going to change that much. So when we look at climate, we're mainly looking at temperature and precipitation. We're going to look at how hot the summers are or how cold winters are and how much rain or snow we get. And do we get it all in one season? Do we get it all throughout the year? Things like that. So let's start with our climate controls. These are the 6 conditions that we're going to look at when we want to determine what climate is. So we have latitude, proximity to water, how close you are to water, altitude and elevation, how close you are to mountains, ocean currents, and prevailing winds. We're going to look at each of these a little in depth, some more than others. So at any time in the video, if you need to pause, do that, and then come back. So let's begin with latitude. Latitude, put a star next to it because it's the most important factor that affects climate. It's your position relative to the equator. So remember, latitude goes like this, these lines. It's how far above it you are or below it. So if you're here at the equator, you can see sunlight is concentrated, which means it's going to generally be warmer. The further up you go or the further down you go from the equator, the lower the average temperature is going to be. Right. Latitude can also affect your precipitation by causing air to rise in certain places. So here at the equator, you get what are called convection cells. Warm air rises at the equator and condenses and precipitates. So that's why you have rainforest at the equator. But that air, as it circulates and comes back down, this air is now dry and it's cooler. And that happens at about 30 degrees north and south, which means at the equator, you're going to have more rainforest. And at 30 degrees north and south, you're going to have more deserts. So you can see that here. So the Sahara Desert's at 30 degrees. The Sonora Desert here in the United States, the Gobi Desert, all those 30 degrees latitude. 30 degrees equals desert. How close you are to water, we've also talked about this somewhat this year. Water heats and cools very slowly, and its temperature range is also pretty low. So if you are in a city next to a big body of water, you're going to have a mild climate. So these are going to be smaller temperature ranges. The summers are going to be cooler, and the winters are going to be warmer. It's going to be more comfortable. If you're far inland, you have a big temperature range. And large bodies of water can add water vapor to the air, which makes it more likely that precipitation is going to happen. So if you lived in, say, New York or maybe Michigan or places like that, you might get what's called lake effect snow. That's what happens when you have cold, dry air from Canada, comes over the Great Lakes, and that water is added and it makes a ton of snow really fast and it dumps it really fast. So here's an example of a lake effect snow that happened not long ago. In 2017, this was up in Buffalo, which is on Lake Erie. They were playing the Indianapolis Colts and they had like a foot of snow or so fall during the game, maybe more. It was really fun to watch. Probably not fun to be there though. All right. Our third climate control is altitude and elevation. So how far up you go. Remember, we live in the troposphere, which is the first layer of the atmosphere. temperature decreases as you go up. So the higher up you go, the colder it is. Let that little thing go away. Go away, little thing. There it is. The higher in elevation of the land, the colder it is generally. So that's why Mount Kilimanjaro, which is the tallest mountain in Africa, even though it's right next to the equator, it still has snow on the top. It's really cold, even though it's so close to the equator. Our fourth climate control is proximity to mountains. Mountains are going to affect the amount of precipitation you get, and it's going to change based on what side of the mountain you're on. So they can make something called a rain shadow. All right, so basically one side of the mountain, you have moist air as it rises, it cools and condenses, and you have rain, so there's your rain shadow. But now the air is dry, it's going to sink and warm back up on the leeward side. That's the dry side. And this is going to be more desert. All right, so lots of precipitation on the windward side where the wind comes in, dry on the leeward side. And we have a couple of examples of rain shadows here off the coast of California, and particularly northern California and up through central. You have lots of precipitation, and then over here east of the Rockies, as you go eastward, this land gets very dry. Same here with the Himalayas. Okay. Our fifth one, ocean currents. This should sound very familiar because we did this not long ago. Ocean currents circulate heat in the ocean. So you have some questions in your notes. Let's look at what those are next to this map. How would the water temperature off the coast of Japan different than the water temperature off the coast of Northern California? So Japan, for those of you that don't know, is over here, and Northern California is right here. So hopefully what you're able to see, this red arrow indicates warm water. I would expect this water off Japan to be warmer than this water off the coast of California, even though they're at the same latitude, so they get the same amount of sunshine. Because you have cold water coming down here from the poles, that makes that water colder. This water's warmer. Where does warm water tend to move? So look at all the red arrows and tell me where they are generally going to, or maybe what they're moving away from. So this red arrow is going up, that one's going down, that one's going down. All your warm water moves from the equator towards the poles. So from the equator towards the poles. All right, and our last question regarding ocean currents. Where is the warmest water based on this map? Red means warm, blue and purple means cold. Of course, the warmest water is going to be around the equator, and that's because it gets the most sunlight. All right, it gets the most concentrated sunlight. And our last climate control we're going to look at are the prevailing winds. All right, all I really need you to know about prevailing winds is that that's the predominant wind direction, and that pushes weather patterns towards certain places. So if you look at like long-term weather forecasts for the United States, if you watch the news and they say, you know, if they start to look at a system, usually those systems start out here in the western United States and then they get pushed towards the east. They're being pushed by the prevailing westerlies because they come from the west. So this is where low pressure systems move toward. Usually it's going to move this way. And we don't have a question on that, so please disregard this little thing here. And let's go to the very last thing in our notes. All right, you don't have to necessarily write anything here. We just have some questions to answer. So, how do we classify climate? Like, how do I describe climate to different people? I'm going to use these systems. Now, this is a fairly broad overview. It does get more specific than this, but this is all I need you to know. Be able to read this chart. We have tropical climates like rainforest, dry climates like deserts, Moderate climates, which is what we are, so write that down. What type of climate do we have? We have a moderate climate where we have warm summers and mild winters. So winters doesn't get much below freezing. And continental and polar. So continental is what you would expect in the middle of a continent where you have that really big temperature range because you're far away from water. And then polar is going to be very, very cold, where your warmest summer is less than 50 degrees. All right, so I want you to be able to read this chart, and if you look at a map, be able to tell me characteristics using this table. So, think about how climate can impact living organisms in an area. There's lots of different ways we could answer this. I'll give you one example. Let's say you live in a dry environment. Okay, like you're a plant. Let's imagine you're a plant. So let's think of a plant that lives in a dry desert environment. Hopefully, you thought of a cactus. If you thought of something else, that's okay. We'll probably get the same idea. Cactuses or cacti have certain characteristics that help them save water. So they have really thick skin. They have what's called a cuticle on their leaves that prevents water from evaporating from them. They also usually have either really deep root systems or shallow root systems that go out like a big net. And that's going to maximize how much water they're going to be able to absorb. And as we all know, plants need water. So that's just one way that the environment can affect what kind of organisms live there. Another good example that's not in the desert, let's go to a polar environment. Think of animals that live in polar environments, like penguins and polar bears and seals and stuff like that. They're either going to have things like thick fur to keep them warm, or a layer of fat called blubber, which again also keeps them warm. If you're a polar bear or an Arctic fox, you have white fur to help you blend in. Those are all adaptations that make you fit that climate better. So you live longer. And that's what ultimately organisms want to do. All right? So once you're done with this, I have a climate assignment for you. You can come get that from me, and if you have any questions, please, please, please bring those to me as soon as possible. Okay, thanks.